Hello there, Math 154 students. I received a request for help with this particular problem, which is 6.3, number 14. Where it is in the particular assignment depends on when you're watching this, what semester, etc. But it would be the number 14 one. It says, use the general slicing method to find the volume of this following solid. The solid with a semicircular base of radius 3, whose cross sections perpendicular to the base and parallel to the diameter are squares. Okay. Well, I'll do the example, not the official one there. So I'll do the one with radius 1, which is the example, but you can apply the techniques that I'm going to show you to whatever particular problem you're doing. Okay, so the thing about a semicircular base is you can kind of put it either way. So let me label this. Okay, so you could go this way, or you could go this way. I mean, either way it works, right? They're both semicircular bases. But the thing is that you want the, or semicircular bases of the solid. But if you go this direction, it said that the base of the square would be parallel to the diameter. So this is the one we prefer because this would be dx. And so we'd be integrating this back to x as opposed to this direction, which would be dy, right? Because you'd be stacking a. So we're not going to use this one. We're going to use this one. Not for any particular reason other than convenience for us. That's the only reason. Okay, so now think about this in 3 dimensions. So if you have your y-axis like this and your x-axis sticking out, this is x, this is y, and then you have your z-axis sticking up, right, your 3rd dimension. So you have a semicircle base right down here of radius 1, right? So it's 1 in the x direction, 1 in the y direction, and so then you're going to fill this with, right? So this line is this line, right? You're going to fill this with squares. I'm only going to draw one of the squares because, of course, it would be really tedious to fill them all up, but that's how it's going to look, right? So you're going to have a square and another square and another square and another square, and it's going to stack into this item and create a solid. All right. The solid would have, kind of a curve coming down, etc., like that. Right? Okay, so although I don't want to draw that in, that'll just confuse everybody. So let me kind of take that out. But you saw that it's kind of there. Okay, so the volume by the general slicing method is the integral from a to b of the area of the slice, which in our case is going to be a square, dx. And we did dx because that will be this version, not dy, which would have been this version, although we could have, right? It would have worked. Okay, so we need to figure out what our x values are going from what to what, and then what our area is. Okay. Well, the x values are pretty easy because if we look at the semicircle, we start over here at x equals 0, and we go to over here where x equals 1 in our particular case because we have a radius of 1. All right, so 0 to 1. So the only tricky bit is really to figure out the area of the cross section, which is this square up here. Now, luckily for us, it's a square. So squares are pretty easy to find the area of if we can figure out the solid, or the side of the square. So we need to figure out what this side is. Right. Okay, well remember that that side is also this side right here, right? It's this distance. So the distance from the x-axis up, right, from here to here, is the square root of 1 minus x squared. Now, if you're thinking, how in the world did you know that? Well, remember, we learn in basic algebra class, a circle is x squared plus y squared equals r squared. And in our case, our radius is 1. So for us, it's x squared plus y squared equals 1. So that means that y squared is 1 minus x squared. And therefore, this function up here, it's actually this way, but I'm not drawing all of it, is the square root of 1 minus x squared. Right? It's plus or minus technically. So the way that works is that the top half is the square root of 1 minus x squared. Of course, we only need the right-hand portion of it. And the bottom half is the negative square root of 1 minus x squared. Right? So that's how that works. So I know that this top piece is the square root of 1 minus x squared. And then furthermore, I know the bottom piece is the negative square root of 1 minus x squared. Okay, well then what's the distance put together, right? It's this function plus itself, right? This function, if you will, minus a negative. Because this piece up here is the same as this piece down here in terms of length. It's not how you write the function, of course, right? The function has a negative because it's below the x-axis, but the distance, which is what we're concerned about because we want to know the length of a side. Length of a side is distance, right? Right? Distance and length are the same thing for this purpose. So that would be, right, this piece over here is the square root of 1 minus x squared, and so is that, right? So there's two of them. One over here and one over here. Half of it's the square root of 1 minus x squared, and so is the other half. When you put them together, you'll have two of them. Okay, so that's the length of a side of this square. There's two square root of 1 minus x squareds, right? There's one up on the top and one up at the bottom, and we just make this positive because it's distance, and we add them up. All right, well then what's the area then? Well, the area of a square is side squared. We learned that in geometry class right, a long time ago. So that means that our a of x has to be equal to, just make sure that this is clear. So that's a side right there. Then the area is a of x, which is the side squared, which is this 2 square root of 1 minus x squared squared. 2 squared is 4, and the square root, when you square a square root, it just becomes the thing that was under the square root called the radicand. And there's our a of x. Right? So this is a of x. So now we can go plug that in. So we can say, hey, I want to find the integral from 0 to 1 of 4 times 1 minus x squared dx. So all of this was kind of on the side to help us figure that out. Cool. And at this point, it's actually a pretty easy integral. So we would bring the 4 out. And then we're going to integrate both of these with the power rule. So I know it doesn't seem like a power rule, but it is, because this is times x to the 0, and then you would raise 1 to the power, so it becomes 4 times x minus, and we would raise 1 to that power, it becomes 1/3 x cubed. Right? You raise the power and then divide by that new power. And we're going to take that from 0 to 1. So that's 4 times. When I put 1 in, it's 1 minus 1/3. Minus, and then putting 0 in is just going to get you 0. So that's no big deal. And then this is 4 times 1, take away 1/3. Well, if you remember from algebra, that's 3/3, right? So pre-algebra. 3/3. 3/3 take away 1/3 is 2/3, which would be 8/3. And since this is a volume, it'd be units cubed, depending on whatever the units were that you were given. Feet or inches or whatever. Now, keep in mind, your problem will be different. Your radius will probably not be 1 for the particular one you're doing, but the idea holds. It's just going to mean that instead of 1, you're going to have some other number up here for whatever your radius happened to be, and that would affect that, and it would affect inside this radical right here. Right? But otherwise, it's going to work basically the same. All right, I hope that helps.